I'm going to give you some tips for PostLab 8, determining pKa. First 3 questions on the PostLab are just you recording pH values from the experiment. Question number 4 gives you the chemical equation for the reaction that took place during the titration. A lot of the substances are being abbreviated because their formulas are very big. And you are going to write an equilibrium expression for the equation. HBCG is an acid, so this is going to be a Ka, and then you're just going to write the products over reactants. This is a balanced equation the way that it's written. Question number 5 says that at the equivalence point, the concentration of HBCG is equal to the concentration of BCG minus. Use that information to rewrite the equilibrium expression from problem 4. So what you're going to do is, in this equation right here, you are going to have the term BCG minus, and what I want you to do is replace BCG minus with the term HBCG. Now keep in mind that the HBCG term is already in this equilibrium expression, so now it's going to be in there twice, but that's the goal, that's the idea. We just want to get rid of this BCG term. Once you do this substitution, then you will be simplifying it, and it is going to simplify down to 2 terms. So that means you'll just have one thing equals something over here, and that's it. And then it says, at the equivalence point of the titration, bromocresol green is green. Over what range of pH values was your solution green? So going back up to your data, your range is going to be, it starts when the solution turns green. This is the starting point of your range. And it ends when the solution turns blue. So the range of pH values when the solution is green is whatever this number is all the way to whatever this number is. In this spot, you are just going to report that range of pH. Like maybe it's going to say pH of 5 all the way to pH of 7. I don't know why I wrote it as 7 o'clock. pH of 5 all the way to a pH of 7. I don't know if that's what it is, so I'm going to erase it. It'll be something like that. Then in question number 7, you're going to calculate the hydronium concentration for the low and high pH values. So that means you're going to have 2 hydronium concentrations, one for your low pH, one for your high pH. As a reminder, H3O plus is calculated by taking 10 to the negative pH. So you'll do this equation 2 times for each of the 2 pH values, and this is going to give you the range of H3O plus values for your equivalence point. Then you will be calculating the Ka values for the low and high H3O plus values. The Ka values, you'll calculate that by using your simplified equilibrium expression. The thing that you come up with in problem number 5, that is going to allow you to answer question number 8. Once you get that done, you're going to calculate the pKa values, and as a reminder, pKa is the negative log of the Ka. So you'll do this pKa value calculation 2 times, one for the low Ka, one for the high Ka. And then once you get those 2 pKa values, you're going to calculate their average. You'll use the low and the high and just calculate the average, like finding the difference between the 2. Last but not least, you're going to calculate your percent error. The actual value of the pKa is 4.7, so you'll plug that in. And then your experimental, that's going to be your average that you calculated in problem 10. You'll plug that in. I forgot to write down here that you do need to multiply this by 100. That'll give you your percent error.